All right, let's get right into it. We all know that space is getting, well, crowded. Not with little green men, but with our own junk. We're talking defunct satellites, old rocket stages, and millions of tiny fragments, all zipping around the planet at insane speeds. So the question isn't really if we should clean it up anymore. The real question is, what's the smartest way to do it? And believe me, the answer is not what you think. So, first things first, we got to get a handle on just how big this problem actually is. Because this isn't some abstract, far-off issue. It's a huge and fast-growing junkyard, literally floating right above our heads. Now, take a look at this chart. The really scary part isn't just that the red line is going up, it's how it's going up. This isn't a slow, steady climb, it's exponential. You can see these massive jumps where a single event, like a collision, creates thousands of new pieces of debris. We are adding junk way, way faster than it's naturally burning up in the atmosphere. The problem is literally accelerating. And look, this isn't just a problem for astronauts and rocket scientists. Our entire modern world, everything we do, runs on satellites. I'm talking about the GPS that gets you to work, your phone calls, global financial markets, how we track climate change, and, of course, the actual lives of astronauts. All of it. Every single piece of that infrastructure is threatened by this debris. So, okay, we're faced with a giant, dangerous junkyard. What's the logical, common-sense way to clean it up? Well, it's probably exactly what you're thinking right now. I mean, think about it. If you've got a bunch of junk in your backyard, what do? You probably start by getting rid of the biggest, ugliest pieces, right? The broken-down lawnmower, the old rusty grill. And for decades, that's pretty much been the main idea for cleaning up space, too. The plan, for the longest time, has been to go after the big stuff, build these giant space nets, or robotic arms, or space tugboats, and go grab those huge, dead rocket bodies and old satellites. It makes sense, right? It feels satisfying. You remove the most mass, you solve the problem. But there's a pretty big catch. And here's the thing. Even NASA pointed out a flaw in this thinking. The classic argument is that we need to prevent something called the Kessler syndrome, a long-term, runaway chain reaction of collisions. And that's true, but it's also an argument about something that might happen decades from now, and that's a really tough sell when you're asking for billions of dollars for a cleanup mission today. And this is where the whole story takes a fascinating turn. Faced with these sky-high costs and far-off benefits, NASA decided to just reframe the entire problem. So instead of asking, how do we get rid of the most tons of junk, they started asking, what gives us the biggest bang for our buck in reducing the immediate financial risk to our active satellites? It was a subtle shift, but it changed everything. They turned it from a physics problem into an economics problem. And to figure that out, they came up with this key metric, the break-even point. They wanted to find the solutions that would actually pay for themselves by preventing expensive damage to working satellites. And more importantly, they wanted to know how fast they'd see a return on that investment. Would it be 50 years, 20 years, or something else? And when NASA actually crunched the numbers, well, the answer they got completely flipped that old common sense approach on its head. It wasn't even close. What their models showed was that the most cost-effective strategies had almost nothing to do with grabbing those big, dead rocket bodies. No, the real money was in two other areas: stopping a collision before it happens, and getting rid of the tiny, untrackable junk. And this chart just lays it all out, clear as day. Look at this, the time it takes for these strategies to pay for themselves. That big, heroic mission to remove large debris, you're waiting over 20 years to break even. Now what about removing the small debris, maybe with ground-based lasers? Less than 10 years. Okay, that's better. But preventing a collision with a tiny, last-minute nudge, the economic benefit is immediate. The difference is just staggering. Okay, so the big question is, why? Why is our gut instinct so wrong on this? Why is it smarter to zap a tiny fleck of paint than it is to remove a whole 10-ton rocket body? Well, it really boils down to this. First, the thing that causes the most day-to-day damage to our multi-billion-dollar satellite constellations isn't another giant satellite. It's the constant storm of small, untrackable stuff, things the size of a marble that can hit with the force of a hand grenade. Second, and this is the real kicker, if one of those giant rocket bodies does hit something, it doesn't just go away. It shatters into thousands of new pieces of that deadly, smaller debris. So by preventing that one single collision, you avoid creating a brand new minefield in orbit. It is the ultimate case of an ounce of prevention being worth a pound of cure.
So, this shift in thinking from mass cleanup to economic risk management isn't just some clever accounting trick. It completely rewrites the roadmap for how we're going to keep space safe and usable for the future. Let me give you a really simple analogy. Imagine you're in charge of making a city safer. What's the better use of your budget? Do you spend $1 billion to demolish one huge abandoned skyscraper that might collapse someday? Or do you spend a fraction of that fixing all the potholes and broken traffic lights that are causing fender benders and traffic jams every single day? NASA's report is basically telling us to go fix the potholes.
So the key takeaways here are incredibly powerful. We need to stop focusing just on removing mass from orbit and start focusing on what reduces our immediate operational costs and the catastrophic risk of creating more debris. This means we should be investing in smart, scalable technologies like lasers that can zap small debris or give big objects a tiny nudge to get them out of the way. And maybe the biggest lesson of all is that sometimes the greatest obstacle isn't the technology, it's just about asking the right question in the first place. In the end, the smartest solution to cleaning up space wasn't found in a bigger rocket engine or a better robotic net. It was found in a better economic model. It really makes you wonder, doesn't it? What other huge, seemingly impossible problems could we finally start to solve if we just stopped looking for the most obvious solution and started looking for the smartest one?